Hi, I would like to thank Oligonucleotide Therapeutic Society and meeting organizers for this great opportunity to present our recent data showing that intracellular BPA distribution and extracellular vesicle recycling define antisense oligonucleotide activity in tumor cells. ASD4785 is a next-generation ASO which was designed to knock down oncogenic KRAS expression. Previously, we found large variability in KRAS knockdown across lung tumor cell lines. In cells with a good productive uptake, we observed very efficient KRAS knockdown, and in cells with a poor productive uptake, we observed literally no KRAS knockdown. So what is the mechanism of the poor and good productive uptake? We know that for the activity, ASO should be internalized by tumor cells, and then it undergoes endosomal escape in the late endosomal compartment. To our surprise, the level of the overall ASO cellular uptake between the cell lines was similar. So therefore, we hypothesized that its delivery to late endosomal compartment, which defined productive or non-productive uptake. To test this hypothesis, we investigated ISD4785 intracellular trafficking in two cell lines, PC9, cells with a good productive uptake, and LK2, cells with a poor productive uptake. We used CD63 as a marker for late endosomal compartment. We found that the majority of ASO is delivered to these late endosomes in both cell lines. LBPA is another marker for late endosomal compartment, and it also facilitates ASO escape from late endosomes. Hence, we investigated ASO delivery to LBPA-positive late endosomal compartment. To our surprise, we observed colocalization between ASO and LBPA only in PC9 cells. To test the functional role of LBPA in ASO delivery, we treated both cell lines with the small molecules, stimulating LBPA production. Interestingly, LBPA stimulation significantly improved productive uptake only in LK2 cells. Late endosomes is also a place for origin for extracellular vesicles. So next, we tested if antisense oligonucleotides can be recycled in extracellular vesicles by tumor cells. We treated both cell lines with ASD4785 and then isolated extracellular vesicles by ultracentrifugation. Interestingly, ASO treatment stimulated extracellular vesicle production by both cell lines. Next, we analyzed isolated extracellular vesicles by using UPLC-MS, and we detected intact ISD4785 in the extracellular vesicles secreted by both cell lines. However, LK2 cells secreted 4.2-fold times more ASO in the extracellular vesicles as compared to PC9 cells. Loading of extracellular vesicles with ASO can result either in the ASO transport between cells or in the ASO clearance from the tumor cells. To test transfer between cells, we isolated ASD4785 loaded extracellular vesicles and put them on the recipient cells. Interestingly, we observed very robust KRAS knockdown in the recipient cells. Next, we analyzed the contribution of extracellular vesicle recycling pathway in the productive uptake by using Rep27 siRNA or small molecule to inhibit EV recycling pathway. Interestingly, inhibiting EV recycling pathway improved productive uptake only in LK2 cells. To summarize, we found that the productive uptake depends on antisense oligonucleotide delivery to LBPA-positive late endosomal compartment. Secondly, it also depends on antisense oligonucleotide clearance via the extracellular vesicles recycling pathway. More details you can find in our recent paper. Thank you for your attention.